This is lesson 5, the heat capacity of metals. In the last lesson, we focused on how heat was exchanged with water, and we were trying to figure out, well, how much heat would it take to raise the temperature of some specific amount of water? And we learned that this formula was really useful for calculating the amount of heat that would be absorbed. So what I want you to do is I want you to take a minute and see if you remember what each one of the variables in this equation stand for. What do they represent? So pause the video here and write those down in your notes. Okay, did you get that Q stood for heat, M stood for mass, which was the mass of the water, C was the specific heat or the heat capacity of water, and that was always 4.184. And then delta T, which really stood for change in temperature, was how much the temperature went up. If it started at 53 degrees, did it go up to 92 degrees? It was the change in temperature. Now this formula is going to be very useful for what we're going to do today as well. And I would definitely keep your paper handy because we're going to do a prediction in the same way we have with previous lessons. And I want you to make those predictions on paper and then transfer them to your Google Sheets form. Okay, so today, what's going to look different is we're going to have water and we're going to compare it to metals if we heat these metals. Which one of these two will have the bigger change in temperature? So today's lesson is focused on being able to use that formula we just had to calculate the heat exchange for metals and not water. But we're also, the other sort of underlying principle in this is we're going to be looking at trying to get a grasp on what heat capacity actually means. Because water may have a heat capacity of 4.184, but metals don't. And we're going to try to get a feeling when we look at a heat capacity number, what it's trying to tell us. Okay, so you've got that piece of paper handy, because I'm going to ask you to record some values down, and we're going to compare how the change in temperature of metals versus water occur. So we're going to take this lump of copper here, and you can see the mass, and I'd say go ahead and record that mass. And I'm going to work really hard here to make sure that we have the same amount of water. So you could see me zero out the balance so that it wasn't calculating the beaker. And then we'll pour in some water. And I'm going to go get a little pipette so that I can add a little bit more water very, very carefully. Because the goal is to get it to be the exact same amount of water as we had metal up here. We'll see how close I get. All right, not bad. Maybe I overshot it just a little bit. So now that we have the amounts of each one, and they're pretty darn close to the same thing, let's make a prediction about what's about to happen here. If we take these two and we put them on the stove, and we assume that the stove can deliver the same amount of heat to each one, what will we see here? Which one of these two, given that they're the same amount of metal as we have water, they're both about 93 grams, which one will see the bigger change in temperature? So what I want you to do is I want you to go to your Google Sheets and make that prediction and see if you can come up with a reason for why you think that. Have you had any experience in your life that would make you predict one would change temperature more than the other?